I'm Anthony Kapkan of Buildings IoT Canada magazine, and welcome to the Buildings IoT Forum session, Private Networks and Infrastructure Supporting IoT with Bryan Jones. Before I continue, a very special thank you to our sponsors of the Buildings IoT Forum, WatchNet and Siemens. Thank you both for your support of this programming. Bryan established his first company in 1998, providing telecom and business infrastructure services for small businesses. As an entrepreneur with over 20 years of experience supporting building technology in varied environments, he is adept at navigating the emerging world of IoT, the convergence of IT IoT, and their disparate systems. Bryan joined Graybar Canada last year with the goal of establishing them as a leader in distribution for the IoT and intelligent buildings vertical. So, Bryan, before I pass it over to you and get you started on your slide deck, tell us a little bit about your background and how you even ended up working in IoT.
It all started in 1998 when Bell deregulated, and my brother and I decided it would be a good opportunity to start installing phone systems. And then we started installing networks. And from there, we recognized an opportunity to uh, work with the connected devices that worked on those networks. And so 22 years later, here I am working with building technology and IoT.
Bryan, now that we know a little bit more about you, why don't we dive right into your presentation where you're going to talk about private networks and infrastructure supporting IoT.
Absolutely. Before I dive in, I am going to tell you a small story, and it's related to the pace of technology. And it goes back to 2001. I was working at a project in Toronto, and it was going to be the cutting edge, the leading technology for residential home internet. We were installing set-top boxes for a virtual in-suite concierge so that the residents could connect to their other residents in email. They could order flowers from the front desk. They could call a cab through their virtual in-suite concierge. And the internet speeds were going to be an unheard of 100 megs per second, which back then in 2001, the speeds that people were getting were somewhere in the neighborhood of 5 megs or 10 megs per second. And so we were putting this technology in on fiber optic with Cisco switches, and it was going to be the technology of the future and never to be touched. And so 15 years later, as the project was coming to a close and we'd finished installing all the technology in these buildings, it was obsolete. And so the point of that story is you can always have the plans to be future ready and future proof. But the reality is we don't know how long the technology will last and how fast the technology is going to change, because the 100 meg connection now is considered slow. I mean, people are now looking at 500 megs, 600 megs in home environments. So it's a story I like to tell when it relates to technology and how things do change and how fast they do change. So we will move on to the first slide here. So today I'm looking at private networks and infrastructure supporting IoT. And I always like to start with this slide. It's building intelligence equals business intelligence. And if you look at what an intelligent building is, one which provides a productive and cost-effective environment through optimization of 4 basic elements. So you have structure, we have systems, we have services, and management, and the interrelationship between them. And if we look at business intelligence in the definition, it's a technology-driven process, so technology-driven, a process for analyzing data, presenting actionable information to help executives, to help managers, and to help corporate end users make informed business decisions. So the technology is used to improve the business outcome. So that's key, and I always like to start with that because I feel it's important that people understand we don't invest in technology for the blinking lights or the cool factor. We invest in the technology for the business outcome. So we're going to get into the IoT piece here. And there's a lot of misconceptions about what IoT is. And a common misconception is that IoT relies on a public internet connection, so public IP. And in fact, it's a part of it, but really IoT is the internetworking of things. It's not the Internet of Things, it's the internetworking of things. And we're looking at machine-to-machine communication. And so really to oversimplify, they're devices with an IP address that speak to other devices with IP addresses. And so that's an oversimplified look at what IoT is. So how many devices are out there? Everybody has seen a version of this slide, and the numbers change by the billions. But if we look at 2012 up to 2020, a dramatic increase in the number of devices, and a rough estimate is that we're going to be sitting at 64 billion IoT devices by 2026. And I would say that we're probably looking at more than 100 billion, and I don't think anybody can really accurately predict that far ahead, but that's a graph that certainly shows from 2012 at 8 billion to where we are now. It's just every year we're heading in a direction and adding billions of new devices. Some examples of IoT devices. We've got surveillance systems, energy meters, thermostats, LED lighting and controls. And then I say sensors, and more sensors. Occupancy sensors, temperature sensors, water, air quality, gas detection. We can sense when the toilet paper is running out. And these are all examples of IoT devices being used in the commercial buildings and residential, retail, and other ones. So we'll move on to. So why do we invest in IoT devices? Thermostats are now room controllers with built-in compute power to sense occupancy, to adjust temperatures, to turn off non-critical equipment and shed energy to keep critical equipment running. Grocery stores are using cameras, sensors, and analytics to determine product placement and even staffing requirements. In commercial buildings, IoT devices are improving the efficiency from parking license plate recognition, sensors determining where available spaces are, elevators know when you're arriving and take you to a specific floor, and the brightness and the color of light is customized to keep employees alert and productive. So now more than ever, with the focus on health and safety and human-centric applications, we aren't just looking at building efficiency. We're actually using the technology and IoT to attract and retain good employees and tenants and keep people healthy and safe at work. So I want to touch on edge computing because it relates to IoT, and it's really changed the way we compute within the building. Anthony, I'm sure you've heard of cloud, and in the first couple of decades, everything was about the cloud. Run it in the cloud, back it up to the cloud. You know, my parents didn't know what the cloud was. They just knew that's where everything was going. And so now we're moving to what's called the edge. And the reason for that is applications like artificial intelligence and high definition video. It requires a lot of processing power, and we found out that the cloud is pretty far away and a little too slow, and possibly the cost of getting that information back and forth was it got to be a little too much. So we moved things to the edge. And so I wanted to make sure that people were aware that IoT is changing the way we compute, and I call it driven to the edge. And it's all about bandwidth and speed and latency, and then scalability. And so I had to give some acknowledgement to where we're going with edge computing. And we don't want to go too far into that because that's another segment for another webinar. So diving into private networks, and I'm going to focus on three. So we have LPWAN, we have 5G, and we have PON. So a private network being a network of connected devices configured for limited and secured access to the public. So IoT does not require a constant connection to public broadband, making low-powered WAN, 5G distributed antenna, a very large growth area for IoT. And then fiber used for connectivity and now extending deeper and deeper into campuses and buildings. So these are the three areas I'm going to focus on today. And we're going to start with LPWAN. And what is LPWAN? Well, it's low powered and it's for wide area. Operates in on small inexpensive batteries and in a wide area with a range in the kilometers. So LPWAN is not a standard. It's actually a term that covers various implementations and protocols, both proprietary and open source, and some examples: Sigfox, LoRa, and Mioty. Why would we go with LPWAN in favor of over Wi-Fi or other technologies? You can securely support hundreds and hundreds of devices with an estimated battery life of up to 20 years. So it's ideal for dense locations. It's ideal for large buildings, for smart lighting, asset tracking, and long-term monitoring of things like water metering, gas detection, remote door locks. And LPWAN technology works very well where devices need to send small amounts of data over wide areas, maintaining a battery life for many years. And you can imagine, if you have hundreds and hundreds of sensors, if we had to replace the batteries every 3 to 6 months, the technology would be sent out the door as fast as it came in, because it would defeat the purpose of saving all the money and being proactive with the maintenance if we had to have the maintenance workers replacing all the batteries. We're going to move on to 5G. So 5G, this is the most widely talked about, currently deployed, yet to be used network. And what it is the 5th generation of wireless communication technologies supporting cellular data networks. Pretty straightforward. 4G was 4th generation, 5G 5th generation. Why 5G? 5G delivers reduced latency for low delay centric applications such as industrial automation, autonomous operation, and high definition video surveillance. 5G has ultra high level resiliency for applications such as end user safety and mission critical applications. And it increases mobility. 5G is designed for high speed mobility, and so it allows for increased and secured roaming. It offers configurable quality of service, which is ideal for mission critical lifeline and production critical automation use cases. So 5G isn't going to be for everything. So we have low powered WAN for sensors, and we have 5G for the more mission critical and where you need resiliency and certainly reduced latency. And I have to give some acknowledgement, because we're not going to be able to get into it, into the other technologies, but they certainly have to be acknowledged. And so I'm going to give honorable mention to Wi-Fi 6, Bluetooth, Zigbee, and Z-Wave. And we're not going to get into all of those, but they certainly need to be mentioned because they're relevant and they've taken us a long way in the IoT space. So we're going to get into PON. And what is PON? Well, it stands for Passive Optical Network. It's a telecommunications technology, and it was initially used for delivering broadband network access to end customers. And you've seen it throughout your residential neighborhoods to give your internet and your TV. Its architecture implements point-to-point, multi-point topology in which a single optical fiber can serve multiple endpoints using unpowered or passive fiber optic splitters to divide the fiber bandwidth amongst multiple access points. So what started out for carriers and ISPs to deliver internet and phone and TV services has now become more widely used for supplying services to the buildings. So as more buildings, I'm going to just take us to the next slide, why? As more buildings choose fiber optic cables over more traditional copper, passive optical networks are allowing for continued to continue to support IoT and let it grow. It allows for buildings to be more reliably connected to numerous devices. One strand of fiber is able to replace hundreds hundreds of copper cables. And that's important to buildings as we run out of space. We need to support more with less. So one strand of fiber replacing hundreds of copper cables to support the same number of devices, decreasing installation costs and maintenance upkeep. So for commercial practices, fiber networking supports multiple connections with different bandwidth needs. And so, in conclusion, and I've been avoiding using the C word, but we have to acknowledge the landscape has changed. And in the last 3 months, whether it be commercial, whether it be retail or residential buildings, really the emphasis is now on employee health and safety. And it's just going to fast track the necessity for connected devices and the demand on our networks. So now you can hit me. Any questions, Anthony?
Now, Brian, taking you back a few slides,
Yeah.
under the low-powered WAN slide, you had mentioned a few technologies. There was Sigfox and IoT. Um, can you tell me a little bit about one of those technologies?
Yeah. So I'm going to elaborate on IoT. Low-powered WAN protocol. One that, in my opinion, will be instrumental in sensor deployment. And the appeal is that one base station can support hundreds and hundreds of sensors for anywhere up to 50 kilometers and perhaps farther. So it uses technology called telegram splitting. And what that means is it splits packets of data under transport in small subpackets at the sensor level. And the smaller packets get transmitted randomly and over different times in different frequencies. So it's actually a standardized technology. It's in the license-free spectrum, and it has data rates of 512 kilobits per second, which for sensors is actually quite fast. And you can accomplish that in 16 milliseconds. And so really key to sensor deployment. And I just want anybody listening to either research it or watch out for it, IoT. And it's coming soon to theaters everywhere. And I think it's going to be a game changer for deployment of sensors as we move forward with IoT.
Oh, very good. Well, I'm definitely going to look up some more on that. That sounds fantastic. Now, you were closing with in talking about passive optical networks and
Yeah.
the capabilities it has. So, I've heard differing opinions on traditional copper versus fiber architecture, but you're clearly leaning toward optical networks to support buildings' Internet of Things.
Yeah.
Why is that?
I'll keep it very simple. Fiber is the fastest. It's very secure. You can connect more devices with fewer cables, and I'll leave it at that. Certainly, traditional copper has its place and had its place, but I think the future and the amount of data we're moving and the speed at which we need to move it, we can't argue that with the speed of light. And so I'll leave it at that.
I like that. Good statement. You can't argue with the speed of light.
You
Um,
cannot.
now, tell me before we wrap this up,
Yep.
Brian. Any closing statements to leave us with?
I guess is that, yeah, closing statement. We can't use yesterday's technology today and expect to survive in the digitized business of tomorrow. So we really have to start embracing where we're going with technology and shift. The past treated us very well, but we do have to move and to navigate those waters. There's a lot of resources, and I hope people would take advantage of some of your resources because nobody has all the answers, and things are moving at the speed of light. And so I just want anyone listening to recognize that there's support out there, and there's no clear answers, but we definitely need to start looking at how to support the business of tomorrow and upgrade our technology.
Well, and to your point, right at the very start of the presentation, what is future proofing, considering how fast things change. But
Yeah,
anyway, Brian, thank you for that. I really appreciate you taking the time to do this with us.
I appreciate you having me. Thank you very much, Anthony.